speakers, Samantha, Larry, the floor is yours.
All right, sounds good. Okay, good morning, everyone, on this lovely Sunday. My name is Sam Cheng. I'm the Global Lead Scientist for Impact and Evidence at the World Wildlife Fund. I'm joined by Larry Kilroy, my colleague at DataKind. And we're really excited to share some of our reflections on developing a free open evidence synthesis tool for the past decade or so. So what we're going to do today is just talk a little bit about where did this come from? What was the challenge this is trying to respond to? Our experiences developing it, maintaining it. Larry will run us through the technical development of this tool and then talk a bit about what's coming next. Okay. All right. So we all know the world is changing pretty fast. And at one point, a reporter in the Washington Post said, what if the solution to all of our world's greatest challenges has already been solved? It's just hiding in a PDF that nobody is ever going to read. And they published this article because there was a report from the World Bank over 10 years ago that out of the tens of thousands of reports they publish every year about their projects, about policy analyses, only a third had ever been downloaded, which does not mean they've been read. And so if you take that alongside the fact that research output is rising exponentially, we're getting new papers published every single year. It's on track to double every 9 to 10 years. So on one hand, right, this is really, really exciting. There's a lot of information and evidence that's out there that we can use as practitioners and policymakers to inform our work. But we need that information in a timely way, in a digestible way, so that's usable, so we can actually feed it into the decision-making processes at the right time. And this is where approaches called evidence synthesis come in. So this is a really broad set of approaches that exist out there. They help us capture, review, and synthesize existing knowledge for specific topics and questions. And so this really came from the medical field. So anytime you go to the doctor, they might make a recommendation. That's informed by medical guidelines. Those medical guidelines are updated based on published literature on a regular basis. And what's really valuable about these approaches is that they're transparent. They aim to minimize any potential bias that might be in those studies that would affect the types of insights you get out of them. And they're also reproducible, meaning that you can repeat that analysis at any time, so you can update the evidence base to keep up with all that stuff that's getting published. So at WWF, we are a science-based organization. We are trying to develop solutions to answer key conservation challenges so that we can halt the degradation of the environment, conserve biodiversity, address all those drivers that impact nature, including climate change and human development, and ensure the well-being of people. But to do that, we need timely access to reliable and relevant information at the timescales that we are trying to make decisions that are tailored for the places where we're working. So in response to this, I feel like I'm aging myself here. Like 15 years ago or more, my colleagues and I, across a number of different conservation organizations and development organizations, said, okay, let's take advantage of the decades of research on conservation so we can understand what do we know about the impacts of nature conservation on people. We thought this was going to be a weekend project. So there's that. And we ended up looking at 35,000 published citations. Taking all that, winnowing it down to about 3,000 relevant articles, and getting to about 1,000 included in that map. And there were a lot of really exciting insights there, which helped us understand where we had known knowns and known unknowns and gaps we needed to address. But it took us 3 years. So by the time we did that, our knowledge was 3 years out of date. And to do it again, it would take us another 3 years. And so it very quickly became a very daunting task of figuring out how we could actually use this on a regular basis to inform conservation work. So that leads me to the second part of the talk, to talk about the challenges of synthesis, to really make them scalable for decision-making on the whole. The first piece is obviously the efficiency. We are taking a lot of time. We have to sort through a lot of stuff to get to that proverbial evidence needle in the information haystack. And so to do this process manually is quite literally impossible. Which leads me to this point that not only are they inefficient, they're also sometimes insufficient to look for the right information. When we looked across the environmental sector, we found that for similar types of studies, authors are looking at around 14,000 citations to get to really only 2.5% of those that were actually relevant to what they were looking for. So obviously there are a lot of reasons why you might not include things, but ultimately what the verdict is here is people are looking through a lot of potentially irrelevant stuff to get to what they need. Which leads to the second challenge. It's really costly. So all that time it takes to search through all those citations costs money. This is a fairly old study, but I think still quite relevant, not accounting for inflation. But on average, $30,000 to $300,000 US to do one synthesis, not updated. And it can take anywhere from 6 months to a few years. And so that's not really sufficient if we want to generate evidence at the timeline that we actually need to make these decisions at. You can imagine somebody in a government agency is like, we've got to pass this policy, we've got to form it in the next couple of months. And we're like, ask us in 3 years and we'll help you. And so any sort of approach we take to making this process faster, we also need to take into account the third challenge, which is the value of these evidence synthesis approaches is that they're trustworthy, they're rigorous. And so whatever the outputs of any sped up process is, we need to make sure that they still maintain this component, because the value of these approaches is that the evidence hasn't been cherry picked to match a particular decision or finding or position. So it's within this context that Colandr was founded and launched in 2017. So what is Colandr? So with the Science for Nature and People partnership that was led at the time by Conservation International, we decided that evidence synthesis was something important that we wanted to pursue and support across the conservation sector. But we needed to find a way to do it faster, more efficiently, and dynamically. And so we partnered with DataKind to develop an open access, open source, computer-assisted software platform for evidence synthesis called Colandr, because you're sifting stuff through to find what you need. And so the way that Colandr worked was really to have an easy-to-use front-end platform where users could input what they were looking at to help them sort through it faster and intelligently label that information. So when we developed Colandr, we had some key features in mind. The first is that we had to maintain a human in the loop. It couldn't be fully automated. Again, right, the value of these approaches is that they're transparent, and we wanted to maintain that trust. So one of the features that's built into Colandr is an active learning approach, where users are maintained through the whole process, maintaining that oversight. And the second is we wanted to make sure that it was open. So at the time that we developed Colandr, over 10 years ago, there were lots of different approaches trying to apply machine learning to evidence synthesis in different softwares. But we didn't know what people were doing. They're opaque. No one was really talking to each other. And so every time someone tried to start something new, they were basically reinventing the wheel. And this took a lot of time and research for our development team to actually dive in and figure out what they were going to do. But then the second part of it was seeing that there's a lot of opportunity to apply these various different AI approaches to synthesis, but we needed to foster some kind of community of practice to learn from each other. And so that was the rationale behind pursuing an open source approach. And then third is Colandr's open access. It's free to use. And this is really, I think, predicated on the challenge that if we want to be able to use evidence, we should be able to use evidence everywhere. Everyone should be able to use it. Some of the biggest challenges in the world, particularly for conservation, are in some of the countries with the fewest resources. And so researchers in low and middle income countries don't always have access to really expensive research platforms and tools. Moreover, if we want to update them, they again cost money. And so this is something that was intended to help accelerate the field forward. Okay, so in the past 10 years, we've seen the user community for Colandr really grow organically. We have over 6,000 active users now, nearly 4,000 past and ongoing reviews that are being conducted. And it's really been used across a lot of different fields. We built this for conservation, but turns out it was applicable and answered a need across health, education, social development, environmental management, you name it. And so what some of those users have used Colandr for are folks like the ISEAL Alliance, who's been using it to extract information about certification impacts, right? Like forest certification, product certification. The American College of Physicians has been looking at the machine learning algorithms that are behind Colandr to help them improve their synthesis approaches in medicine. And then for us at WWF, we are working to harness some of the work in Colandr to help us figure out how we maintain living evidence in conservation. But the other thing that's been really exciting is that this community of users has helped grow some of the features, right? We built Colandr as sort of an initial tool. People then came and said, this is great. We want to build some add-ons. We want to build tools that can complement and enhance its functionality, leveraging things like R so that they could create trackers and create things that would pipe the outputs to other tools. They've been helping track the research performance, conducting studies, comparing Colandr's performance to other tools that are out there, and providing feedback on how we could continue to develop it to respond to changes. But this also raises some of the challenges. In 2016, Colandr was built by a team of volunteers working on their nights and weekends. And then over the past 9 years, it's continued to be maintained by these volunteers with sporadic support from various institutions, really following me around to multiple institutions over time. But we've been lucky that we've had a really supported and committed user community that has allowed us to continue to see the value in maintaining this over time. But it's on that note that I'm going to hand this over to Larry to talk about the technical development and what's next for Colandr.
Okay, hopefully that helps. Excellent. All right, so the technical development of Colandr. DataKind is an organization, or a nonprofit organization, and we're trying to close the gap between the access that non-social impact organizations have and they use every day, and social impact organizations use every day. So this was an early application of machine learning, and a lot of the base machine learning we're using was key in the development of what we now think of as Gen AI in large language models. And so Colandr was built as a two-system approach. One, looking at inputs of search results from existing systems, and the other, uploading articles for full text assessment. And we'll dig into each of these. So on the first, we're using a technique called word-to-vector, developed by Google in the early, around 2013 by Google researchers. And it's a technique that transforms text into numerical vectors. We have a little example here where it takes the I like NLP and I love cats, and based on the association of the words, starts to create a scoring system. And so the way Colandr uses this is we use it to identify co-occurrences of words around user-friendly key terms. And we actually read the abstracts and provide relevance to that. And this is what the System 1 diagram looks like. The second technique we're using is referred to as GLOVE, which is global vectors. So we're capturing global vectors. Most of this work is in the English language. So capturing in the English language, and we are generating word vectors based on occurrence and relevance statistics, and then it calculates a probability of given words, what they actually mean based on how it's used in the presence of other words in the system. So this is a slightly different flow. So we would read in actually like a PDF and then apply this technique. So we aren't pulling any other information from another abstract system. So all of this, and I'm going to jump, I hate to do this to everyone, but thank you for your inspiration. We're going to do some live stuff. That whole back end goes out to a REST API. So right now, we have built a user interface. It's based in English. But our hope is that with this published API, others can build their own applications to it. So, basically all the documentation is here. For example, it's easy before you commit to building to go ahead and we would provide any organization tokens and authentication. You can just try it out in this interface before you commit to writing any code. So that's the basis of that, what we call the back end. And then we have built a front end, and this is meant to make it easy to use. Here we go. Oh, there we go. It's working. Knowing we're limited on time, I'll just show a couple of the key features. Actually, I'm going to back out. Well, I'll do this first, and then we'll kind of go in reverse. So here, there's some basic tools. You can have quite a bit of these uploaded citations, especially coming from a system. It might be hundreds at a time. And so this is meant for teams to use. So teams of researchers can go through and use this. And you can sort by relevance, or you can sort by recently added. If we go ahead and pick one, then you have the information you need to go ahead and start cataloging. If you wanted to enter a tag, I'm just going to say, I'm going to say water. Keep it interesting. This is the test database. Don't worry. And then that allows you to eventually, filter by all the different tags that have to do with water, et cetera. And then, of course, you can go ahead and include it or exclude it. So similar to the system we just saw. And then once it's included or excluded, it'll be, in the completed phase. If it's in conflict with another reviewers, it shows up in that conflict, and then it can be resolved going forward. Again, knowing we are limited on time, let's just go quickly. Why don't we take a quick look at, we wanted to make it easy for importing information into the system. So, we just have a basic import here, get some data information, make sure you can identify the data source, et cetera. And then it's pretty much drag and drop. So you can drag collections in here, things like that, keep that very simple. And with that, I'm going to skip back because we're wrapping up here and I'll go back to full screen. That was the human in the loop part. So that is how we maintain that human in the loop. So what's next? So as Sam mentioned, it's been maintained by a very small group. We're hoping to expand that. As we get more users, particularly more university users, we've had requests, can we contribute to the code? So we wanted to make some changes. The early versions were written in Scala, which is a JVM language, so not as well used these days by researchers, especially not used at all. So we've refactored that entire backend to Python, something that can be used. We've also, as you saw, that's the brand new API. We've refactored the API to a fast API, which used to be called Swagger. And we've rebuilt the front end in React.js, which is one of the most popular JavaScript languages. So should be easy to contribute. The big thing, anytime you're getting any kind of input, we've also had to build out our test suite. It didn't have a lot of coverage, so that way it's easier for our team to test any incoming pull requests and merge. We're up on GitHub, MIT license, so people can take this and improve it. The next thing we've done is we have, through email primarily, which Sam has been the full customer support, we have brought in all of those that we started creating a GitHub issues. And we're hoping that, especially for people who are early in open source and want to get their public commits up, this is a great place to start, find an issue, solve the issue. And then finally, we're establishing maintainer policies. Hopefully not the same 4 people. We'll be doing it all the time. So how people can also help maintain and approve that coming in. And the last step is very new, which a lot of the ML we're using has been used in creating LLMs. But now we want to explore how LLMs can also supplement this work. And that'll be a big focus in the next year or two. With that, thank you. And questions? And I'll make this mobile, so depending on who has the answer. We'll start left to right.
With Colandr 2, are you looking at redesigning the user
So interestingly enough, a lot of the feedback we got. You have to repeat the question. Oh, the question was. Thank you. That's why I just put my glasses on. The question was, are we considering redesigning the user interface based on feedback that we've gotten from Colandr 1 to Colandr 2.0? The answer is there are a number of changes we've made because Colandr 1 wasn't up to date with all the various standards like GDPR and others. So when we hacked those in, they became pretty ugly. So it's a much better looking interface, but for the major features, we've actually got a lot of feedback that the simplicity of the user interface is one of the selling points of this version of Colandr. So we don't have any major changes planned except for improvement around like the drag and drop technology, things like that, and making sure that that's updated and maintainable. We do hope that there will be contributions of new features though, and that if it requires some adjustment, we would do. Yep.
Where did the research article come from? Are you limited to open access?
I'm going to hand this to Sam, but the question was, where do the research articles come from? Are we limited to open access?
That is a great question. So if you're a Colandr user, you have to use your own access licenses. So whether you're at a university or wherever else, you are the one searching for those publications and uploading them into Colandr. So it won't search the databases for you.
The question is, I mentioned Colandr 2 is coming soon. How soon? Hopefully within the next 6 weeks. We're in final testing right now. And then I saw a hand over here.
As someone who does conservation research, I've done it for many years. Thank you for what you do. My question is, I saw the words include and exclude on the demo you did just now. So for any particular paper, right, what Colandr did tell me, quote unquote, why is suggested including or excluding?
The question is there is an include and exclude function during that review process, and would we have the reasoning that someone else could access why it was included or excluded?
That is a great question. So because all decisions in Colandr have to be made by a person, when you say include, it meets all the criteria. Your team should have met and decided these are all the things it must fulfill. In the exclude, when you click on it, it gives you a whole set of options. You can define all those options yourself, right? So say you're interested in studying the impact of restoring mangroves on storm surge, right? You get a lot of storms, it can reduce flooding. And you might say something like, oh, this paper is about mangrove restoration, but it's not looking at the impact on storm surge reduction. So you'd say no, like irrelevant outcome or whatever. So you can really come up with any reasons you want. You can add whatever tags you want, and that's to keep that whole process transparent. But it's not going to tell you you should include this or you should not include this. It's just going to say this seems more relevant to what you've been saying is relevant.
And I'll just add, that's an area we're thinking about where LLMs could be helpful. It could, synthesize what all different teams have said about that, and then we can maybe have some sort of suggestion feature. Oh, yes.
Have you considered using OpenAlex as a source of papers to include in the review?
I'll let you repeat the question because.
Do you say OpenAlex? Well, one, I have not heard of OpenAlex, so I have not considered it. So the question was, have we considered using OpenAlex as a source for reviews? So I think that's a great suggestion to the evidence synthesis community, right? So the choice of where you look for papers and where you look for information is really important. You look in, a really small database, you're going to have a small set of things that come back. But I think that's something to go back to, okay, where are the open source resources that we can be relying on as an evidence synthesis community that are actually going to allow us more visibility to all the things that are out there. But Colandr at the time doesn't pull from it.
All right. Well, thank you.
Thank you.
Thank you. So, next up, we are going to stream a video from a speaking that couldn't make it because of visa consideration. What?